Okay, in this video, we're going to have a look at instantaneous rates of change. So we've had a look at finding a rate of change of a straight line. Okay, it's the gradient of our straight line. Okay, and we looked at some average rates of change. Now, average rate of change, an interesting one, it was found by putting a line between our 2 points and finding the gradient of that line. Okay. So we can do a similar thing to get an idea of our instantaneous rate of change, because our instantaneous rate of change is the gradient of the line at the given point. Okay, now we're going to get to more sophisticated ways of doing that, but we can still do this through our ideas of average rate of change to get a really close approximation to what the gradient actually would be, okay, or our instantaneous rate of change would be. So we've got a function here that's y equals x squared. So nice, just quadratic that we've got. We've got a point here that's point P, and it's the point 1, 1. And we've got this other point Q. Okay, so if we have a look at this, if I draw a line between the two, okay, now this line here, okay, is called a secant line, okay, and this part of the curve in between is called a chord, okay. But what we want to do for our average rate of change, or just our rate of change between P and Q, right, is going to be the gradient of this line. Okay, so let's actually think about what's going to happen, okay, with that for a particular value of Q. Okay, so let's say we're looking at the point, let's say 2, 4. Let's say it's the point 2, 4. Okay, then our rate of change, okay, is going to be y2 minus y1, so 4 minus 1 over 2 minus 1, 2 minus 1. So that's going to give us 3 over 1, which is just 3. Okay, so the rate of change of this line, okay, is 3, or the gradient of that line is 3. Now, we can see though that really the slope of the line looks like this, so we're not actually that close. But what we can do is we can actually make this closer. Okay, because we can pick a value, okay, say in here, and make that Q now. And that Q might be 1.5, then that would mean we were 2.25. Okay, so we can come somewhere in the middle now. So when we do that, okay, we're going to look at our rate of change again. Oh, sorry, so this is the gradient, sorry, this line now. Okay, and we'll say our rate of change now is going to be 2.25 minus 1 over 1.5 minus 1. That's going to give us 1.25 minus 0.5. Okay, so our rate of change now is going to be 2.5. Okay, so we're getting a little bit closer there. Okay, and we can keep doing this. Okay, we make it closer again. Okay, if we move Q down here and we say, let's make it this time 1.1, okay, then that means we're going to be 1.21, okay, when we square it. Okay, then we can look at this line here. We're going to see our rate of change. It's going to be 1.21 minus 1 over 1.1 minus 1. Okay, so that's going to give us 0.21 divided by 0.1. It's going to give us a rate of change, okay, of 2.1. Okay, you can see here that what's happening is we're getting closer and closer to the actual gradient that we want. So we can see that this first line, okay, wasn't a particularly close approximation to our gradient here at this point. But this one's closer and this one's closer again. If we keep making that closer and closer and closer, okay, then we're going to find we get closer and closer to the actual value. Okay, so what the actual value is, okay, is the gradient of a tangent at that point. Okay, and that's because our very definition of a tangent is a straight line touching a point on a curve and having the same gradient as the curve. Okay, that's what a tangent is. Is a line that has same gradient to the curve where it touches it. Okay, so we can make this closer. Okay, and we could do this. We can simulate this on our calculator. quite simply, okay, we could set up a table if you like, okay, to keep working out some values. Okay, so you see we've gone 3, 2.2, 2.1. Okay, if we keep going here, let's say we went really close and we said now we're looking at Q being the point, let's say it's 1.0001. Okay, so when we do that, we will get a value for Y of 1.00020001. Okay, so when we look at our rate of change for that one, okay, we're going to get 1.00020001 minus 1 over 1.0001, okay, minus 1. Okay, and when we do that, okay, we find that we are going to be getting very, very close to 2. Okay, and that is actually the gradient of the line at that point is 2. Okay, and I know that because we've got more sophisticated ways of working this out. The idea here, okay, is our instantaneous rate of change can be approximated, okay, by continually finding the gradients of lines very close to it by reducing the distance between the point we're looking for and some other reference point. Now, similarly, you could have actually had a Q value down here on the left-hand side of P. Okay, that would have been fine. It's just that this now would have been X2 and Y2. Okay, and the values at this point would have been X1, Y1. And funnily enough, we would have started below 2 for our gradient and worked up to 2, where this way we started above 2 and worked down to 2. So we're going to be very similar there. Okay, so that's the idea of what we're trying to do here. Okay, so I think that's all we need to cover in this section. Okay, again, you can use your calculator to work with some of this stuff, but I don't think we'll worry too much because we're going to very soon find out how to actually do this stuff and get the exact value very soon. Okay, so the main idea is that the gradient of a secant between 2 points, okay, is going to get closer and closer to the gradient of the curve, okay, as the distance between our 2 points get closer. So hopefully that's enough to get you through some of the work on this section.